A lone Falcon 1E stands ready on its launch platform at Vandenberg Air Force Base.
Nine, 8, 7, 6, 5, 4, 3, 2, 1. T0 plus 1 plus 2 plus 3. We have liftoff from SpaceX Falcon
1. The first stage liquid oxygen and kerosene Merlin 1C engine hurtles the rocket towards space with a 556,000 Newton thrust. As the rocket approaches an altitude of 90 kilometers, the first stage reaches burnout and separates from the rocket, falling towards the Pacific Ocean. The second stage Kestrel engine ignites at approximately 99 kilometers, its liquid oxygen and kerosene propellant giving the rocket a 30,700 Newton thrust to reach the operational orbit, a circularized sun-synchronous orbit at 630 kilometers and inclined at 97.91 degrees. The fairing separates, exposing its payload to the harshness of space. Once the rocket reaches the appropriate orbit, the spring-loaded light band adapter pushes the satellite out without the use of pyrotechnics or creating any extra debris. The satellite begins its first operations. It first establishes low-rate communications with the ground station, communicating its location, pressure, and thermal readings. The main thruster and 1 Newton thrusters fire to make final corrections to the orbit and gain initial attitude control. The satellite then expands its solar panels and begins tracking the sun, drawing its first taste of solar power. The telescope shutter opens and the primary patch antennas deploy, enabling the satellite to begin establishing nominal data rate communications in the S-band. The control moment gyros, the primary attitude control system, begin their run-up to full operation and then take over attitude control. Once the system checks out, the ground station gives the command for ToBaLo to begin using its sensor. Initial alignment of the telescope, validation of optical performance, and verification of attitude and location determination is conducted. A series of predefined reconnaissance operations of known satellite locations is conducted to verify pointing accuracy and jitter control. Finally, a test scan of the geobelt is conducted, and the satellite is ready to assume normal operation. ToBaLo continues to orbit the Earth focused on the geobelt. Its lapses in coverage due to the solar exclusion zone are picked up by its 2 sister satellites flying in highly elliptical orbits at a 0-degree inclination. The constellation is capable of revisiting every satellite within the geobelt at least every 3 hours. And so begins its 3-year mission.